Okay, my name is Teodor and I'm your physics teacher. Today we'll see about grade 10 physics unit 1, that is two-dimensional motion or motion in 2D. From this, first we'll see about projectile. Now, from the name, projectile is a motion which can, an object is thrown or an object is moving upward, and this movement, if it is without an engine or motive force, we can say it's what? Projectile. The projectile. But for example, if it is not restricted, that means if it is the object is moving with other motive force or an engine, that is not a projectile motion. When you throw a stone, toss cricket balls, or kick soccer balls, and others are some examples of projectile. For example, another which cannot be a projectile motion is rocket. Firing a rocket when it moves up, there is a flame below or at the bottom of the rocket. That flame makes the object by action reaction force to move up, therefore it has an additional force to move upward, therefore it's not a projectile motion. Such types of motion is not a projectile. But if there is no motive force or other motive force or an engine to move the object upward, if the object is moving initially by the force applied on the object, we can say that motion is projectile. Now, projectile is some more complex than one-dimensional motion. This involves motion in two directions, the vertical and the horizontal. That means we have two motions, horizontal motion and vertical motion. Therefore, we will see this separately. We will see vertical motion separately and horizontal motion separately. For simplicity, we first resolve the velocity. Since the object is moving in such a manner, it has a vertical as well as what? A horizontal velocity. A vertical velocity and a horizontal velocity. Therefore, we have two velocities, horizontal velocity and vertical velocity. We can resolve or split this one single velocity into two component velocities by using vector resolving technique. Therefore, resolving means splitting one vector into what? Its horizontal and vertical component, and the components have the same effect as the original vector. This one is true. Therefore, let us see first the horizontal motion. If we ignore a resistance, that means in this situation we neglect a resistance. We consider if there is no a resistance, then there are no horizontal forces acting on the projectile as it flies through the air. This means there is no acceleration. This one is only for the horizontal motion. If we ignore a resistance, and then there are no horizontal forces acting on the projectile, the only force is the upward or the vertical forces. That means which makes the object moving upward. Because of this, the acceleration is 0, and this acceleration is 0 means we have a constant, or the velocity of the horizontal motion remains what? Constant. Therefore, v horizontal is constant throughout the motion. From the starting up to the end point, the horizontal velocity is constant. And we can apply the following equation to find the horizontal displacement. As you see here, we have a horizontal displacement from this up to this point. And this horizontal displacement is named as range. And we can calculate this range or horizontal displacement by using the equation. As you know, velocity is equal to what? Displacement over time. And if you make crisscross, displacement is equal to what? Velocity times time. And from this, the displacement is horizontal displacement, and the velocity which we use is what? Horizontal velocity times which the object is needed to move from this point up to this point is we call it flight time, because the object is on air between these 2 points. Therefore, we use the time as flight time. So, in order to determine the range or the horizontal displacement, we use this equation. That means horizontal velocity times flight time. The other thing is vertical motion of the projectile. In the vertical motion, the vertical velocity does change, or always it changes. Let us see. This one is the projectile, and when it moves up, it decreases, and when it reaches a maximum height, it becomes what? Constant. And when it moves down, it's what? Increasing. When we say constant, it doesn't mean a constant value. At the maximum height, at this point, it is what? 0. Therefore, at h max, the vertical velocity is 0, and when it moves up, it decreases, and finally it reaches 0. After that, it moves down. When it moves down, it's increasing. And ignoring a resistance, what the acceleration for this vertical motion is always 9.8. That is gravitational acceleration. Therefore, for the vertical motion, the acceleration is what? Gravity. For this reason, this vertical motion of projectile is considered as uniform accelerated motion, because the acceleration is constant, that is g. Therefore, since it is the vertical motion of projectile is considered as an example of uniform accelerated motion, you must take care on this point. It doesn't mean that the projectile motion is an example of uniform accelerated motion, but the vertical motion is an example. እዚህ ጋር በደንብ ጥንቃቄ ማድረግ አለባችሁ። ምክንያቱም ይሄ ማለት ፕሮጀክታይል ሞሽን ራሱ የዩኒፎርም አክሰለሬትድ ሞሽን ኤግዛምፕል ነው ማለት አይደለም። ምክንያቱም ፕሮጀክታይል ሞሽን ስንል ሆሪዞንታል እና ቨርቲካል ሁለቱንም ስለሚይዝ፣ ነገር ግን ቨርቲካል ሞሽኑ የዩኒፎርም አክሰለሬትድ ሞሽን ኤግዛምፕል ነው። ምክንያቱም ቨርቲካል ሞሽኑ ላይ ቬሎሲቲያችን አክሰለሬሽናችን ምንድነው? ኮንስታንት ነው፣ ግራቪቲ ነው። ሆሪዞንታሉ ላይ ግን ስንመጣ አክሰለሬሽኑ ምንድነው ብለናል? ዜሮ። ምክንያቱም ሆሪዞንታል ቬሎሲቲው ኮንስታንት ስለሆነ። ስለዚህ ሆሪዞንታል ሞሽኑ ዩኒፎርም አክሰለሬትድ ሞሽን ስላልሆነ ቨርቲካል ሞሽኑ ብቻ ስለሆነ የሆነው ፕሮጀክታይል ሞሽንን ኢን ጀነራል ዩኒፎርም አክሰለሬትድ ሞሽን ነው ማለት አንችልም። የምንለው ምኑን ብቻ ነው? ቨርቲካል ሞሽኑን ብቻ ነው። ስለዚህ the vertical motion is an example of uniform accelerated motion, but the projectile motion is not an example of uniform accelerated motion. Only the vertical motion is an example. Therefore, since it is an example, we can use the uniform accelerated motion equation for this vertical motion of projectile. ስለዚህ ይሄን አምስቱን እንጠቀማለን ማለት ነው። ዩኒፎርም አክሰለሬትድ ሞሽን ኢኩዌሽኖች ይሄንን 9ኛ ክፍል ላይ በደንብ ተምራቸዋል። when we use this, the first, the displacement is missing. In the second, the final velocity is missing. In the third, no, in the second, it's not the final velocity. It is the acceleration. And here, the final velocity. Here, the time. And here, the initial velocity is missing. Therefore, this one is displacement, acceleration, final velocity. Which one? Final vertical velocity. And time t. And initial vertical velocity. Therefore, we have one missing, and the total variables are how much? 5. From this, among these 5, one is missing from each equation. Therefore, each equation have 4 variables. Therefore, when you apply to use this for 5 equations, you must have 3 given and 1 required. Therefore, when you get 3 given and 1 required, 1 is missing. Therefore, you must select the missing equation. For example, if s is given, t is given, and u is given, if you are asked to determine acceleration from among these 4, 1 is missing. Which one? The final velocity. Therefore, you must select the final velocity missing equation to do this example. Therefore, let us see one example. Find the time taken for a ball dropped from a height of 6 meters. Dropped. Since it says dropped, the initial velocity is what? 0. And we are asked to determine what? Time. Time t is how much? And since it says drop, initially 0, and the acceleration is what? Gravity. Therefore, we have how many givens? 3 givens. This, and this. And you are asked to determine, and the height is given. Height, initial velocity, acceleration is given, and we are asked to determine what? The time. What's missing? The final velocity is missing. Therefore, since the final velocity is missing, you must select the final velocity missing equation. Which one? The final velocity missing, the third one. That is s is equal to ut plus half of at square. Therefore, s is equal to ut plus half of at square, and u is 0. Therefore, this part becomes 0, and your equation becomes s is equal to 1 over 2 at square. From this, if you solve for t, multiplying both sides by 2 to s is equal to what? At square, and dividing by a to s over a is equal to what? T square, and finally t becomes what? Under radical of 2s over a. And finally, if you substitute the values, you can get 1.1 second. This one is approximated value, but when you divide, you can get 1.1 something numbers. Therefore, when you approximate, you can get 1.1 second. 1.1 second. Therefore, you must do by using these techniques. Okay, we have another example. Do the second example by yourself, or let us see it. Okay, when we see the second example, find the final velocity. The required is what? Final velocity. This is required. The second example is expressed, or the question which is related with the first example. Then when we use, the time is also known, and this one is unknown, and the acceleration is also known, and the initial velocity is known, and s is known. Therefore, only v is unknown, and you are asked to determine v is how much. To do this, you have 5 questions. Among these, one is missing. In one of the 5 equations, v is missing. Which one? The third. In the other 4 equations, v is present. Therefore, you must select the other 4, one of the 4 equations you must take, because you know the 4 values. እዚህ ጋር አራቱንም ታውቃላችሁ። ይሄ ሁለተኛው ኤግዛምፕል ከመጀመሪያው ጋር ሪሌትድ ነው። የመጀመሪያው ላይ ታይምን ዲተርማይን አድርገናል። ስለዚህ ዲስፕሌስመንት፣ ኢኒሺያል ቬሎሲቲ፣ አክሰለሬሽን እና ታይምን እናውቃለን። ስለዚህ ቬሎሲቲውን ፋይናል ቬሎሲቲን ለመስራት 5 ኢኩዌሽኖች አሉ። ከ5ቱ ኢኩዌሽኖች አንዱ ላይ ብቻ ፋይናል ቬሎሲቲ የለም። ስለዚህ እሱን ብቻ ነው ምንተው። ከዛ ውጪ ባሉት አንደኛው፣ ሁለተኛ፣ አራተኛና አምስተኛው ኢኩዌሽን የፈለጋችሁትን ወስዳችሁ ብትሰሩ የቫልዩ ልዩነት የለውም። ደስ ያላችሁ ወስዳችሁ መስራት ትችላላችሁ። ብቻ የተጠየቃችሁት ቪ ስለሆነ ቪ የያዘው ኢኩዌሽን መሆን አለበት። ቪ የሌለው ሶስተኛው ላይ ብቻ ስለሆነ ሶስተኛው ሲቀር አንደኛውን፣ ሁለተኛውን፣ አራተኛውን ኦር አምስተኛውን መጠቀም እንችላለን to determine the final velocity. Therefore, I use the fourth one. And in the fourth one, v square is equal to u square plus twice of as. And since we are asked to determine v, under the value of u square plus twice of ac and u 0, and finally rearranging this, you can get how much? 11. Okay, the other thing is, how does this affect the motion of a projectile? That means how the horizontal and the vertical velocities are affecting a projectile. The effect of horizontal and vertical velocity in general, they make the path of the projectile what? Parabola. When you draw the motion of projectile, always you must write, or you must draw in such a manner, because it's parabolic, and this parabolic path is created or caused or affected by what? The horizontal and the vertical velocity. The horizontal velocity makes the object to move in the horizontal direction, and the vertical velocity makes the object to move in the vertical direction. And the combination of the two makes parabolic, because the horizontal velocity is constant throughout the motion, but the vertical velocity is what? When it moves up, it is decreasing, and at the maximum height 0, and when it moves what? Increasing. Therefore, because of these two effects, the path becomes what? Parabolic. And let us see one example. When we use the 5 equations, you must take care of the initial velocity and the gravity. The initial velocity is always, initially the object is moving in the vertical direction, and gravity is what? Down. U is up and G is down. Therefore, since these two are opposite, one of the two must be negative. Let us see one example. An arrow is fired vertically with an initial velocity of how much? 35 meters per second. Find its velocity after what? 3 and 6 seconds. Using the table layout seen earlier, let us take out the givens. For the first, s is not given, and the final velocity is given. No, the initial velocity is given, and you are asked to determine what? The final velocity after 3 seconds and 6 seconds, and the gravity is also known, or the acceleration is known. But here you make either initial velocity negative or the acceleration negative, because they are in opposite direction. In this case, I make the initial velocity negative. That means the upward motion is negative, and the downward motion is what? Positive. Therefore, for A, after 3 seconds, since S is missing, the S missing equation is the first one, therefore V is equal to U plus 80, and when you substitute, and finally you get how much? Minus 5.6. Minus 5.6. This minus sign indicates that the minus sign is the upward motion, therefore in 3 seconds, at 3 seconds, the object is moving what? Upward still, because you got a negative value. A negative value. For B, after 6 seconds, you got how much? 24, positive. Positive. This indicates that since it is positive, positive is downward motion. At 6 seconds, the object is moving down. Down. Therefore, the negative and the positive sign indicates the object is moving up or down depending on the negative you select. If you select a negative sign for the upward motion and you got a negative value, the object is moving at that time upward. If you select the negative side for the downward motion, and if you get positive, the object is moving upward, and so on. Therefore, it depends on the selected values. The selected values. Okay. The other thing is horizontal projection. Horizontal projection. Projectile may be initially traveling horizontally, just like firing a gun. Firing a gun. When you fire a gun, the gun initially, or the bullet initially moving horizontally, and then what? False. False. Therefore, initially the object is moving in the horizontal direction, and finally it changes to what? Projectile, half of projectile. Therefore, because of this, we name the such types of motion is horizontal projection. Horizontal projection. Let us see one example, or I have one question for you. The first, this question is: if we fire a gun in the horizontal direction, the same mass and the same type of bullet, if you drop down, which one reach first on the ground? Which do you think? Both reaches equally. Both reaches equally, because always in the vertical motion, either horizontal projection or free falling, for the time t, in both cases, we will calculate under radical of what? 2s over acceleration a or gravity g. Acceleration in this case is gravity, since it is vertical motion. In both, for this situation as well as this situation, both depends on what? The displacement, because acceleration is what? Constant, gravity. Therefore, the displacement means the height. Therefore, since they are at equal height, the time taken to reach on the ground, both reach at the same time, or they are reached at equal time. Therefore, if you are asked to calculate the flight time for horizontal projection, you must use what? T is equal to under radical of 2s over g or 2s over a. A is the acceleration. In this case, it's gravity. You can make under radical of what? 2s over g also. 2s over g also. And if you are asked to determine the horizontal projection, no, the horizontal displacement. Horizontal displacement is equal to horizontal velocity times flight time. Therefore, the flight time is this one under radical of 2s over g. Therefore, for horizontal projection, you can calculate the horizontal displacement or range by using horizontal velocity times under radical of twice of s over g. Now, the other thing is projectile at an angle. In projectile at an angle, the projectile may also be traveling at an angle if it is launched from the ground, and if it is at an angle, we can have two component velocities, the horizontal and the vertical velocity. Let us see that first. When we launch, we have what? The object is moving in such a manner. We have what? Angle theta, and horizontal and what? Vertical velocity. And v horizontal is equal to what? The initial velocity u times what? Cos theta. And the vertical velocity is equal to u times what? Sin theta. You must remember this from your grade 9 knowledge. And if you are asked to determine the time taken to reach this h max, you are asked to calculate what? Half flight time. But if you are asked to determine the maximum height h max, you must use this equation. H max is equal to u square sin square theta over g. You can also see the derivation. The derivation is also expressed, therefore see this by yourself. But we use this equation, that's h max is equal to u square sine theta, sine square theta over 2g. And when we apply this equation, you must take care on the square value. For example, if you are asked to determine for angle is 30 degree, sine square of 30 degree mean that first you must take out sine 30, that is 1 over 2, and then the result is squared. Therefore, it becomes what? 1 over 4. You must apply in such technique. The other thing is flight time. We have two types of flight time, as I told you: total flight time and half flight time. Half flight time means that the time taken to reach the maximum height. And if you are asked to determine the total flight time, you must apply that twice of total flight time is equal to twice of u sine theta over g, and t half is equal to what? U sine theta over g. That means half of the total flight time, and t half is the time taken to reach the maximum height or the half flight time, and this one is the total flight time. Then if we are asked to determine the range, we have also expressed the general equation of range. Range is equal to what? Range is equal to v horizontal times what? T flight time. And v horizontal is, as we see, u cos theta, and t flight time is twice of u sine theta over g. Therefore, you can substitute these two values, and rearranging this, you can get what? U range is equal to twice of u square cos theta sine theta over what? Over g. Or by using double angle equation, since 2 sine theta cos theta is equal to sine 2 theta over t over 2, and you can get range is equal to what? U square sine 2 theta over g. You can apply one of the two equations. Therefore, we can use one of the two equations to apply or to calculate the range if it is launched from the ground. We have some examples here. Let us see. In the first example, find the range of a projectile launched at an angle of 50 degrees with an initial velocity of how much? 30 meters per second. Therefore, you are asked to determine range, and the angle is what? 50 degree. Therefore, theta is 50. You can, if you need to apply double angle, u is the initial velocity is how much? 30. Therefore, you can substitute 30 and square sine of how much? 100. We can use double angle. Therefore, theta is 50. 50 times 2, 100. And then this square is 900, and sine 100 is 0.9848 divided by 9.81, and finally you get 90.35. This one is the range value. And the other thing is find the flight time for a cannonball launched with a velocity of 60 meters per second at an angle of 30 degrees. T flight time, that means the total flight time, is equal to twice of u sine theta. U is how much? 60. You can substitute 60 times sine of how much? 30 degrees. Sine 30 is 1 over 2 or 0.5. 120. 2 times 60 is 120 times 0.5, and divided by 9.8, you can get 6.1 second. If you are asked to determine the range is equal to what? Twice of u square sine theta cos theta. You can use the first equation, that is twice of u is 60 square times sine of 30 cos 30, and finally when you multiply and divide by 9.8, you can get 320 meter. Okay, maximum range. The total angle of projectile affects its maximum range, and the angle affected the maximum range or the value of range. As you see from the diagram, if it is 50, it's at this point. If it is 30, at this point, and if it is 60, also equivalent to 30 and 60 is what? Having equal range, and 50 and what? 75 also have equal range, and the range is maximum at 45 degree. Therefore, that this indicates that sine 45 cos 45 is equivalent to what? 1 over 2, and this one is cancelled by 2. And finally, if it is asked to calculate the maximum range, we use what? U square over g, because sine theta cos theta is 1 over 2, and we have 2 is cancelled by 1 over 2, and finally we have left with what? U square over g. And if you are asked to determine the maximum range, you must apply this, and we can get a maximum amount of range when theta is equal to how much? 45 degree. Therefore, the range is maximum when theta is 45 degree. And if the angles are complementary angles, that means the sum of theta plus alpha, no, phi, is equal to 90 degree. If you use theta to find the range, and if you use phi to find the range without change in initial velocity, you can get equal amount of range. For example, so if you use 30 degree to calculate the range, and if you use 60 degree to calculate the range is what? Equivalent, because the sum of the two is what? 90 degree. And if you calculate at 50 degree and 75 degree, you can also get equal value. Therefore, range of 30 degree and range of 60 degree is what? Equal. Range of 50 degree and range of 70 degree is also equivalent. You must know this. And if the object is determined or launched from above some height from the ground, you must calculate the range by using what? This equation. Here we have a new variable. This variable is h. H is what? The height which the object is launched. Using this equation to determine the range of the ball in the figure below. For this, if you are asked to determine to calculate the range, the height is also given and the initial velocity is given. And finally, by substituting these all values, you can get 131.16 meters.